In the last video we had a look at making a metal from an acid. We took a metal and an acid and we made a salt. Then I've left a couple of links. So we've done in the past, we've made from copper sulfate, we've made copper sulfate from copper oxide and sulfuric acid. So we've done that video and I didn't see any point repeating that one. So we've also done making it from a carbonate. So our next job is to have a look at neutralisation and the pH scale. I'm going to take an acid and an alkali and I'm going to react those together, and we can do this in a burette, but this time we're going to do a slightly different experiment. I'm going to have a look at it using a special thing called a drop counter made by a company called Pasco, which is some quite nice kit, and we can then look at this and it can draw us the graphs of what's going to go on. So let's have a look. Now pH is a weird scale. It's measured from sort of 0 to about 14, from acid to alkali, and it's sort of an odd scale, doesn't really make much sense. So let's have a look at some of the substances and see what they are and what they do, and then we'll find out what happens. So let's go over and have a look at some of the chemicals. Right, I've got set up here the drop counter, which we're going to have a look at in a minute. But first, what I want to do is have a look at a couple of different substances. And what I've got is, let's take a little beaker, and what I'm going to do in this little beaker is perhaps take a substance. This is sodium sulfate. We can have a look at this. Now we can look at this with this stuff, universal indicator paper, you've probably seen before, and if we have a look at this on here, we can see this is our pH scale. This is the indicator paper, sort of a yellowy colour, and we can see that we go from pH 1, dark red, lighter red, orange, through to green, and then into the sort of darker greens, blues and purples of the alkalis. So let's have a look at a couple of these substances and compare them with this little chart. So I'm just going to take a little bit of some of these substances and have a look. So this is sodium sulfate, and I don't need very much. And let's test this with a piece of universal indicator paper, and let's just put it in, and here this is coming out somewhere in the middle. It's sort of about pH 7, looks about right. So that's that one. Let's look at some stuff here. This is lime water, and we'll just try a little bit of lime water. And immediately you can see we've got a different colour on here. It's not gone terribly even, has it? But lime water is sort of, yeah, I'm not happy with that one. Let's do that one again. I expected it to all go the same colour. That's slightly better. And here we can see we're looking at around about pH 10, maybe 12. Well, up there it's looking more like about pH 9, but about 9, 10, somewhere around there. So that's fairly alkali. If we want to look at something a little bit stronger, I've got what's called H8c Ammonia. This is quite strong. I can tell it's quite strong because people are collapsing around me for the smell. And fortunately on here we're not on smelly vision, but it's quite a dark colour, and we can see that's around about, I don't know, 10, 9, 10. At the top it's quite darker, that looks almost 12 to me, so doesn't seem very accurate, this. Let's look at perhaps something a bit different. This is 1 molar acetic acid. This has a common name, this is vinegar. And here is an acid that's looking around about pH 3 to me. So quite strong. Now I've also got some other ones to have a look at. I've run out of little beakers, I'm going to slightly bigger beakers. And for my last one I've got some 1 molar hydrochloric acid. And we can see that this, got it upside down, but that way round. We're definitely on about pH 1. The question comes, if this is pH 1, what pH do you reckon we've got on 0.1 molar HCl? Will it be the same, or will it be, because it's less concentrated, will it be perhaps different? So let's take a little bit of this. I'm only putting it in a bigger beaker because I've run out of very small beakers. So same acid as before, and we'll see that it's maybe very slightly less, but basically still around about pH 1 here. It's quite a strong acid. What I'm going to do is just put my indicator away again, and there we are, put the lid back on, and there's my indicator paper safe. Right, so what we're going to do is we could, oh, just forgetting, I could have used solutions on these. I've got universal indicator solution. I've got now my different beakers. There they are. And what would happen if I put some universal indicator in there? and we can see that that's the acetic acid. So there's our 1 molar and 0.1 molar. There's an acid. Here's our sodium sulfate, and we can see that we've got some alkalis. So we can do the test with the paper. We can also do the test with the universal indicator solution. The paper is simply made by taking some blotting paper and soaking that in some of this universal indicator solution, and we put that solution on there and it will dry and dye that paper that colour. The fact it's got some red on it probably suggests I've got some stuff on my hands. We'll worry about that one in a minute. But before I do that, I want to have a look at this piece of equipment. It's a drop counter. And how does it work? Well, very simply, we take some water and we put the water in here. I've got a little bit of water, and what I'm going to do is just put a little bit of water in. And what will happen is, let's just take this up a little bit, and I'm going to move it out the way, because what I'm going to do is I'm going to take the drop counter at the moment right out of the way so you can see how this one works. Okay, what I've got is I've got a pipette. Well, it's a syringe really. It's got some water in it, and it's got two valves. It's got a valve at the bottom, which I'm now going to close, and it's got a valve at the top, which I'm now going to open. The valve at the top lets water out, and this one I'm going to open fully, and we're going to see that it's working extremely well. So let's stop that, and what we're going to do is I'm going to put some more water in here, but this time we're going to close the top valve a little bit. Let's open the bottom valve fully. I always like it when it doesn't work. And I've set it so that it's now putting drops out. And what I can do is I can slow this valve down so it produces a drop much more slowly or quicker. So I'm now producing about 1 drop a second. Now hopefully these drops are all the same size, and then I can switch this off with this one. Right, down the bottom, what have I got? I've got another piece of equipment to have a look at, and Paul's just going to bring the camera down to have a look at this one. And this is a magnetic stirrer. We've got this little bullet here, and what I'm going to do is put the little bullet into, this is just water, and if I turn this on, we should find that I can make this spin. Now this is really good because it saves me having to stir, and we can get really quite a bit of welly on this going round, giving it a blooming good stir. Now if I don't want to use that one, and the only way now is to try and put my hand in and get the thing out, what I could do is take my drop counter. I didn't give myself enough room. And let's have a look at my drop counter there. This is the drop counter, and it's got a little sensor in here, and every time a drop goes it's going to count it. Also connected to this is a pH probe and a thermometer. I'm going to put these into the water, and what I want to do is I want to record the temperature and the pH. Now if we turn this on, what I've got at the bottom is another magnetic stirrer. This black thing at the bottom rotates and what this does is just stirs the water up as we're going along. So that's going to help my reaction work a little bit better, because I'm going to mix everything up. So I've got a pH probe, I've got here a thermometer, and what we're going to do is we're now going to set up this drop counter so that it's going to drop through that little hole. So like this, so I can set the drops going, and every time it goes you'll see the little counter, little thing here, measures a drop, and it counts up what we're doing. So before we start this experiment, what I need to do is I need to take some water, put it through the drop counter, but instead of putting it through here and measuring the pH and measuring everything else, what I'm going to do is I'm going to fill up a measuring cylinder. So if I take a measuring cylinder, a 10 ml would have been ideal here, but I've got a 25. And what I'm going to do is I'm going to drop the water into here, and we're going to count how many drops of water are necessary to fill up, let's say, 10 mils of water. So I've put the drop counter in place. I've got my measuring cylinder. I hope directly under. And what we're going to do is we're going to go over and look at the software. A couple of things here. I've set up my chemistry sensor with my pH probe, and I've got my drop counter. So what we need to do is we need to count up the number of drops. So I'm going to get here and I'm going to just get rid of this. I don't need this one. I'm just going to put in my digits, and I'm going to select here my drop counter, and I'm going to count by number of drops. So I've got my drop count, And let's set this recording, because I can work out now how many drops make 10 centimetre cubed. It's all ready to go there. Our experiment is ready to go, and so I'm going to now open this. My drop counter, counting the number of drops. And if we have a look at this experiment, we can see that I'm waiting now until we get to about 10 centimetre cubed. I want to work out how many drops are going to make 10 centimetre cubed. I'm doing this reasonably fast, and part of the reason doing this reasonably fast is I want to do this fairly quickly so we can see what happens in the reactions. We're not quite there yet. I need another couple more drops. Not quite yet. Another two, I think. That was three. I lied. And there we have 10. So 10 centimetre cubed, and that was, if I have a look at this, I have a problem. Data collection stopped due to hardware error. I do love that. Do you think I need to do it again? Unfortunately, I think I probably need to do that again. Right, so we will do that one again. So I got 126 drops last time, so I'm just going to record that as a number. So I've got 126 drops equals 10 mils. Let's do that one again. Really, when we do this, we ought to do this several times. So the software is ready, and this is ready, and let's have a go at doing this again. The good news is the dropper is working. I want about 126 drops anyway, so we can work out where we're going to start. I'm going to run from 10 to 20 this time, and it should be about the same number of drops, so we can see what's going on. So we've got an idea of how many drops. So let's go over and have a look at the experiment at this point and see how we're doing. And we're still quite a way off 20. You can see we're up at about 17. $19 and a half, and about a couple more drops. There we are, 20. And here a much better answer, something I was predicting here, about 167 drops. So 167 drops equals 10 mil, so therefore we can work out the size of one drop if we need to. We're nearly ready to start. What I want to do is I want to have a look at how an acid reacts with an alkali. So we've emptied that. That's set ready to go. I don't need my measuring cylinder anymore. We can put my thermometer in place, and I can set that to be roughly the same height as the pH sensor. I will take the wire out of the way. We're going to stand it on this, and what I'm going to do is I'm going to put some acid in there, and I'm going to measure against some alkali, and that's fairly easy. So we've got some hydrochloric acid, and I can decide whether I want to put that in either the drop or I can use the sodium hydroxide. And we want some sodium hydroxide. Oh dear, it does appear that we've run out. Well, that's not really a problem, because what I've got is some sodium hydroxide, and we need to make up a solution of sodium hydroxide. To do this, I need a volumetric flask. This is a 250 volumetric flask. This holds 250. I'm going to make up that amount. I've got my balance ready to go, and we're just needing to work out how much of this we require. So let's go over and have a look at some maths. It sort of goes hand in hand with it. So we've got some sodium hydroxide, and it actually tells me the molecular weight here is 40. I didn't even need to work it out. So molecular weight of sodium hydroxide equals 40. Now I want to make up a 2 molar solution of NaOH, and I have 250 mils. Now let's see what I know. If I wanted to make up a 1 molar solution of NaOH, that's going to be 40 grams of that in 1000 centimetre cubed of water. We haven't got 1000 centimetre cubed of water, we've got 250 centimetre cubed of water, so we want a quarter of that. So that means we're going to want 10 grams of that if we want a 1 molar solution. But I don't want a 1 molar solution, I want a 2 molar solution with 250 centimetre cubed, so that tells me I'm going to need 20 grams of this. So let's go over and see if we can measure how much. And I've been very good here. I've actually forgotten the only thing I need, which is a weighing boat. And my little boy's going to run round and get one for me. It's in the chemistry box. So let's go over and see if I can work out what we need. Now I'm going to weigh out on here 20 grams of sodium hydroxide. We're going to put all of that sodium hydroxide in here, but I'm only going to put so much water in there. And the reason I'm only going to put so much water in there is to get it all to dissolve, and then we'll make it up to this level here. Gives me the right amount. And Paul's brought me one of these little weighing boats. Right, so let's take my weighing boat, I'm going to zeroise this, and let's move that out of the way so you can see what's going on. So all I need now is pipette all the bits and pieces we want. Right, so let's have a go. I want 20 grams. 4.6. That wasn't helpful. Bit too much. Right, 19.98. Now unfortunately I have managed to spill a little bit, so what I'm going to do is I'm going to be a bit naughty and I'm just going to move that off. 19.4. Let's just take the last little bit in here. And 19.99, there we are, 20. Okay, we can put that safe. And what I want to do is, I'll just turn that off. Now I want to put that in here. I want to try and make sure that I don't spill any. So I'm just taking my time over this. There we are, got the last little bit in there. So there is my sodium hydroxide in there. And what I'm going to do is I'm going to add some distilled water. Now, at this point, this is relatively safe. And we haven't been playing around with anything nasty. But now I am. I could have put my safety specs on before, and perhaps I should have. But in fact it's relatively safe playing around with this powder. But as I now put in some water, this is now becoming sodium hydroxide solution. Now when sodium hydroxide is a solid, it's not particularly bad. And I've put in some there. I'll put a bit more in. What I can feel now that you can't see is if that is getting a little bit warmer. I'm going to put the lid on, and now I'm going to give it a good swirl. What I could do with this, of course, is that's now quite warm. It's getting to the stage where I wouldn't really want to hold that. Dissolving quite nicely. let's put a little bit more in. Now I'm going to take it up when I put this in. Just going to give it another little shake. When I do this, I'm going to take this up to about this sort of level. I've got down a bit lower now so that I'm actually on my hands and knees here, down here. I'm a bit lower, and that's because I want to see what's going on. So let's put the water in here. And there I'm nearly at the line, but not quite. What I'm going to do now is I'm going over to my wash bottle, and I'm going to put in this from the wash bottle, still distilled water. I'm trying to make sure that you can see what I'm doing, and I'm going to put that in the sodium hydroxide, which won't have done it any good. And there, I've got 250 mils of sodium hydroxide. Let's give it a good mix. And now I can put that into my reagent bottle so that my volumetric flask can be used again for something else. And if all went according to plan, I've got 250 mils of sodium hydroxide ready to go. Okay, let's have a look at this experiment. What we're going to do is we're going to put some 20 mils of acid in there. We're going to put some sodium hydroxide at the top. We're going to put the two together and we're going to see what's going to happen. So let's set this up. Sodium hydroxide I'll pour in there in a minute. We've got some acid I want to put in there, and I've got my measuring cylinder, and let's put in 20 centimetre cubed. Now for this experiment I don't have to be quite as accurate as I do on some of them, because on this we're just trying to have a look and see what's happening. There we are, 20 mils of acid, and let's put that in here. I could have put it in a burette, I could have played with it differently. We've just opted this experiment. What I could have done is a titration using something like this, a burette. This is a plastic one and it's exchangeable, so we can take this bottom piece out and replace it when students break it. Otherwise they tend to be more difficult to replace, and quite an expensive piece of kit. These work out sort of between £5 and £10. The expensive ones go up to about 20. And what I can do is I can put my acid or alkaline here and titrate it against that using a indicator. Not universal indicator, but something that made this up. One of the indicators being either thymethylene or phenolphthalein. We've got my acid. I'm going to put my alkali in here, and just so I don't make a mistake, I'm just going to bring it across, and we're going to put in enough. So I'm going to put in probably about 40 mils. There's my experiment ready to go. Let's bring this all across and set it up. So I'm going to bring in this down here right to the bottom. I'm going to turn on my magnetic stirrer. So that's going to move the liquid around. My chemistry sensor's in the way. pH sensor. Right, so I've got my acid in there. I've got the thermometer and it's stirring. We can then lower this drop counter. So this will now go in, and we can count the number of drops required to neutralise this. Let's go and set up the experiment. Do a different experiment this time. What we're going to do is I'm going to get rid of this. So let's have a new experiment. I don't need that information. And what we're going to do is I'm going to do one of these classic templates. We're going to select various measurements. I'm going to record the number of drops. I'm also going to record something else. I could record in here something like my pH, and I've got my drop counter there. It looks like I've lost my pH counter. There we are, connecting. Error failed to connect. I love this. No, I don't want to upgrade it. Right, okay. And I've got my chemistry sensor. That's good. So I could select now my pH, and we're going to put here my pH, so we can look at this as we're going to compare it with times at the moment. And then the other bit I'm going to do here is I'm going to put in another graph, and this one we're going to measure temperature. So we're going to measure the temperature. We're also going to measure the pH as we run this experiment. So let's set this going. So I'm now recording the pH and I'm recording the temperature. I am concerned my pH is quite low. That's about right, in 26. Let's see what happens then when we set this experiment going. So we're now putting in the drops of alkali. You can see them at the top there dropping in. And if you look at the experiment, press the right button, we can see that immediately our temperature is going up. pH isn't doing very much, it's staying around about the same. In fact, my pH seems to be changing a little bit, which is a bit worrying. And my pH sensor seems to be going way off. Oh dear. So looks like my pH sensor's not responding. I did calibrate it earlier. But we had a failure. So we can see that where we're now getting the acid and alkali reacting, the temperature is now increasing, and what I would expect to see is the pH staying constant and then changing suddenly. It still might, so we're going to keep going for a few more moments. pH is changing slowly, and what I'm hoping is then it's going to change suddenly. And there we go. The pH suddenly changes and it goes from acid to alkali, and we've reached the end of the experiment. We can see now the temperature reached a peak and is now stopping. So let's now stop this experiment. I'm going to stop the alkali going in, and we can then try and have a look at what sort of values we might have. So what we can do is we can record at certain points what's actually happened and what's gone on. Looking at my data, then we can see that the temperature has increased as the reaction went on until this point, which relates to when we got the equivalence point on our pH. So what I expected the pH to do was to stay constant, and it should have been a little bit higher than that. It should have been about 1. I don't know what went wrong there. So it was marginally lower. I didn't expect that to happen. So that should have been a much more of a straight line, a little bit further up, and then at the equivalence point the pH suddenly changed, and this is where, when we do a titration using a burette, you can put just 1 drop in there, and that makes all the difference at that point. Now, what can we work out? Well, what we can do is we can go back through the data here, and what we can do is we can count the number of drops. So I can count up how many drops for the pH, and we can get to this point where the pH changed dramatically, and it went from, as we can see here, about 0.36, 0.17, 43, 18, 2, 3, so it's about here. So it's 363 drops, the equivalence point. So what I had was this number of 363 drops of sodium hydroxide reacted with 20 centimetre cubed of 2 molar hydrochloric acid. We know that 167 drops equals 10 mil. So what would 1 drop be? So 1 drop is going to be 10 mils divided by 167, but we don't have 1 drop, we've got 363, so we can multiply that by 363. Let's go over to the calculator and do some calculations. So this is going to be 10 divided by 167 times by 363, and that gives me 21.73. So 21.73 reacted with 20 cm cubed of 2 molar HCl. And there is my little experiment. If my solutions had been both absolutely spot on, then they should have been the same. I'm reasonably confident on my solution that I made up of my sodium hydroxide. The 2 molar hydrochloric acid that I bought is exactly that, just what I bought, and I rely on somebody else having set that up and made it exactly right. It's not far off, but it looks like it may not be absolutely spot on. So there we are, a little experiment looking at the neutralisation and pH. This equipment, then the drop counter, counting up the drops, the pH probe, it is working, it's just the calibration went off very slightly. The thermometer here showing you that when acids and alkalis react, this actually gets hot, and here I can see that it actually has done that. I can feel it's hot, let alone anything else. So that's now slightly alkaline. It's actually quite warm where it's reacted. We've got our magnetic stirrer then, which is a good way of trying to save time and make life a lot easier. When I was mixing up this solution, what I could have done is I could have put a bullet down there and I could have got that to mix rather than me having to do the mixing. So Make up a solution. We've looked at acids and bases, we've looked at how they react with universal indicator, and we've also done an experiment here to try and obtain a pH curve, something that looks like this. I hope you found that useful, and it's experiments like this that sometimes you miss out at school, and so that's why I've had a go at trying to do one of these so you can see it in action. And you've seen now a drop counter, which is a different way of trying to work out what goes on. If you like what you saw, then please subscribe, and I will see you same time next week when we'll have a look at some more GCSE Chemistry topic by topic. Until then, goodbye and stay safe.